And for those of you that are asking, we will be recording, so I'll try again. So again, welcome to the IDL webinar. For those of you that are doing the BPI, this is me. I am a building analyst, proctor, building envelope, and IDL with BPI. I also am actually an official IECC Code Council certified for a residential and commercial energy inspector and residential building inspector in general, kind of encompassing. So I have maintained those since 2006, I believe. So, and behind the scenes, which you've already heard, is Jay West himself. So he'll be answering some of your comments and chiming in every now and then as we go through the webinar. So, again, this is sponsored by RetroTech. They're the ones actually are providing the time for this, and we're using their license to do the webinar. So please visit their website if you're looking for any more information or anything about the products. If you're looking for past webinars or any other information, we provide a variety of stuff from testing exhaust fans to blower doors to duct testing, all kinds of stuff that's on YouTube. So please go to the YouTube site if you're looking for more information. All right, so here's one that you must be aware of, that if you do want your CEUs, we did not have you register ahead of time. So please make sure in the question box, if you did it once, please go ahead and do it again if you want. So give us your full name, your email address, and your BPI member ID. All right. And you must be paying attention, which means that your screen for the webinar is active, because what it actually will do is keep track of you. If you see these little yellow indicators, those are actually things we can kind of see, but we really don't maintain them. And it actually spits out a report as to whether or not you are paying attention. So do not be the sleepy cat who was not paying attention or was doing email or other stuff at the same time, because the report is automatically generated. We cannot adjust that. So answering the polls and taking care of maybe some few chats or having this be your active screen is definitely the way to go. Here's our goals today. We will talk about the exam itself and what that entails, some basic business opportunities or who else can benefit from actually being IDL certified. I will have an IDL overview as to what it actually encompasses or what it entails. We will also talk about some I forgot the either IECC requirements in local jurisdictions and who can perform the test, and we'll go through actually fundamentally how to do a total leakaged outdoors and a blower door test. So we're getting lots of feedback here from folks. So if you do have a question, so we can help identify all of the information that's on here, throw it in as question, and then we can actually try and grab that quickly. So there's a lot of BPI information here. So if you have a question in the question bar, put question, and then let us know what it is. So it's easy for me to scan through and find your question, obviously. If we do have any code officials out there, building officials, I always take the time to thank you for all your efforts. I personally think it's one of the thankless job that's out there. It's very difficult to follow and pursue and make sure all of the codes are being implemented and still have some kind of relationship with the builders, which you kind of see every day. So if you're looking for more information or any kind of training, please reach out to us. We do a lot of training for builders and code officials for free. So anything we can do to offer a special webinar or any kind of training, just let us know. So the focus it's called Just the Test and Nothing But the Test, because that's really the basics behind the IDL. It was really designed to provide a gap that was in the IECC code requirements of people who needed to be doing the testing, and there was a real vague notion as to who was allowed to do that or who was actually trained or certified. That's always been a challenge or an issue for some of the code implementation as to, okay, we want to require this or do this, but who is allowed to do that or who can do that? So BPI felt that there was a major market sector that was out there that was already doing similar things. So from builders themselves to especially HVAC technicians or installers or insulation installers. I've also trained people that do pest control on how to do this, because a lot of this is just similar other technical applications that they're used to doing, and they feel for their builder it's a one-stop shop. So if you fit any of these areas, it's definitely something you might want to consider as adding to your repertoire. The blower door is a very quick and simple test. The duct tester may take a little longer. We have a building official here in Georgia who actually felt that they should also be the one providing this. They charge the same as everybody else. They actually do the DET, which is duct and envelope test here in Georgia. And they actually make enough money. They pay for their equipment in 6 months, and they now have a part-time staff person to help facilitate those tests and keeping track of the paperwork as well as other stuff. So don't feel as though there's any kind of limitation for what your normal market sector might be. So we do have a couple of polls that we will do. So as soon as I can see one that kind of fits our slide, I will throw that out there. It does help a lot for your attention level to participate in the polls. That puts your ranking much higher. The faster I get to 80%, I call it done. So for those of you that are out there that want to make sure you're paying attention, give us your answer. So we're looking for what kind of market sector or industry would describe you: low income or high income, weatherization. Are you a private like auditor or somebody who's doing evaluations? HVAC or home performance, which I think are ultimately going to become one big unit. Maybe you're an insulation installer or other contractor, or maybe you fit a different criteria, building official, builder, or anything else that I did not was limited by 5 choices. Don't hesitate to throw that in your options. So we appreciate all your feedback. We're at 77. I have to give it a minute to make sure everybody felt they had the chance to chime in. So we're close to 80. All right. We're going to close the poll, and I'll show you who's out there. We have a lot of home performance and weatherization folks kind of dominating the area, and a variety of others that may be building officials or others. So we appreciate all your time for those of you that are doing private work, and that's actually a pretty good number for the insulation installers. So we appreciate everybody who's here today, and I will hide that. All right, and get back to moving on. This is actually kind of cover what is the test. So one of the things I want to cover was the test and who can do it. The previous slide also kind of covered your business opportunity. So make sure we did acknowledge that. So this is a single measure. It's not a multi-point test. Pardon me. It is proctored and run through the BPI system. So you can't just go to a library and take this test. It's actually more of only a field test type of requirement. You need an 85% as your passing score, and this, as all other certifications, last for 3 years, and you'll be recertified after that by completing the exam again. The MSRP is the $200, which I put in there, is really the test fee. So if you don't feel you need any training because you've been doing something similar, you just want to go sit for the exam, it's recommended around $200 for any of the test centers that are out there. If you feel you need training and want to take the test, that ranges depending on the trainer and the center and what all they're offering, how long of a training they'll do depending on your knowledge level. So if you do want to find more about this, the BPI website obviously is the place to go. So on their website, you can go under documents, policies and procedures, and at the bottom is the Infiltration Duct Leakage Handbook. And we actually have that as a handout, as a new feature on webinars. So if you can see your handouts in your little control panel, you can download the handout, and we also have the field guide for you. So this is what the handbook looks like, and this is one of the pages in there that kind of simplifies what the focus is. Talks about do's and don'ts and cancellations and other criteria, but in general, this list here follows the field guide in general. That you're able to the ability to do this and share your knowledge. If you're not taking a BPI exam in the field, they really ask you to think out loud. That's really your goal. You need to be able to explain to the proctor as to what it is you understand your knowledge. Jay?
Yeah. I just want to mention that for those of you who are familiar with the home energy professional certifications, this is the job task analysis. So this is basically what you need to be able to do, the abilities that you need to do to competently perform this job.
Thank you, Jay. Excellent. One of the criteria that's actually in the exam, and I don't remember the actual percentage, but this is actually one of those fail criteria, kind of a concept, that is, you must explain and demonstrate the priority to document the conditions and the setup and the preparation. And obviously that's to create repeatability confirm your compliance, so you know you actually did what the IECC compliance was about, and obviously reduces your liability. So, and it's really important to walk outside for this kind of test. A lot of people will show up, they go inside, they start setting up their test, and they do that. So I do have some things about the blower door and places you should check. But in general, you want to make sure you do actually evaluate the outside and inside. And for the blower door, the crawl space and attic, and a few other areas that are high priorities that some people just assume are in acceptable conditions. These are the uh, actual field guide criteria. So I want to know that you can, combustion appliances are set to pilot, and basically, if you go through this as a checklist, you'll be able to pass the exam, and you can understand just the simplicity of it. It doesn't really go into detail about how to technically run the blower door or a duct tester. Or duct blaster, whichever you prefer. It actually is designed to make sure you understand how to perform the test. And that leaves some of the details about the individual equipment up to the manufacturer and the proctor to make sure you understand how to actually work that equipment. Jay?
Oh, Joe, we had a question. I thought it was relevant. Question is this just pen and paper, or is it a practical test?
Yeah, it is actually only a practical test. There is no written test that goes along with this. That's why some people find it very appealing. All right. So again, here's where you go forward. Well, your field guide is there. That's what we had. And these are things that are available that are out there. We actually also gave it to you. So there is no written exam. You actually are just going to be able to demonstrate your ability to set up a duct tester and do a duct test, and also to do a leakage to outside test, which now includes a blower door, and also do a blower door test by itself. So if you have questions about the certification requirements, if you can't find them on BPI, Matthew would love to hear from you. Of course, a positive or negative. He's open to all kinds of feedback. So Matthew Anderson is kind of one person to really kind of oversees this certification. So it is, again, a practical test only or field test only. It can be done in a house. Some testing organizations do use house simulators or a test house themselves. So you may not be in a real house, but it actually simulates the same conditions itself. And I really want to stress that this is a code compliance test. A lot of people are like, oh, that's crazy. They just show up and they just do a quick test and now they're BPI certified. And they are, and it's for new construction, which has very specific conditions. It's not intended to do diagnostics. It's not intended to do existing homes or find out what kind of problems they are. That's where the building analyst, envelope, auditor, all the other certifications come into play. These are more of a controlled environment. You would expect that a new construction would not have some of the extreme conditions of leaky ducts, leaky envelope that you might find in a house that's 30 years old. The building science part is actually in a separate certificate. That's the building science principles. So if you really want to get both, these are great stepping stones to get you really acclimated or ready for the building analyst, energy auditor, envelope professional. These are all the things that are a great entry level certifications or certificates to get your understanding. And the reality is, it's just a code compliance test. There's not a lot more into it. So it's more of actually the ability to set up, run the equipment, and determine if they're actually passing the ICC code. So if there's anything else that deals with diagnostics, we really highly, I and BPI recommend you consider more of a much more advanced 3 to 5 day type of training that goes much more in depth in the building science principles in general, building science applications. All right. Any other questions real quick, Jay, before we kind of dig into some code and other stuff?
How about the question? We have we've got some good questions. They're flying in. Question about the field guide rubric. Have you seen it, Joe, or do they need to contact BPI about that?
You mean just to take the exam? That actually is one of our handouts we have, and Jay can also will post the links to send you directly to BPI, so you can download the field guide. I gave you some screenshots there, and that's exactly what you're being tested on. And ironically, in the last line, it tells you the math. It will tell you how big of the house you actually have to do your calculations for. So there's no surprises when you actually are doing this exam. So I know that my area for my duct tester is 1100, and my envelope is 14,300 cubic feet. Hopefully that helped. Yeah.
Is this certification required? Oh, sorry, Joe.
No, yeah, I saw this. Some people say there are a proctor. So I think the grace period may or may not have ended in terms of being able to automatically, offer the exam as a proctor. So I would actually have you send an email to Matthew. I'll bring his slide back up at the end, or actually maybe Jay could post it. So there's some of those kind of questions are really more beyond my ability to confirm how BPI stands on that. So they are available for the proctors. I know all that stuff has now been out there and it's public. There are several test centers that are offering these exams already. All right. Anything else you got, Jay? All right. So let's see if people are still paying attention or if they're sleeping cats here. Let's do a. Oops, hide that one. Let's do a. Well, let's find out real quick. Do you have what other certifications might our viewers have? So building analysts and building auditor or energy auditor are kind of the same concept now, depending on which avenue you kind of went, whether you were weatherization or just more of a private or contractor. The envelope professional, the BSP is the building science principles. For those of you that have not actually addressed that although the guide is phenomenal, the test is not a walkthrough. It's definitely something you really want to be on your game to do that. Maybe you're a Q leader or QCI or others or something else that you that fits your category. Please let us know. And if none of those fit your needs, you're welcome to just pick one to show that you are paying attention. So that way you can make sure you get your acknowledgement that you are here and paying attention. So I guess we should always have other for those. So if you're not one of those, just pick one so that way we know that you're paying attention. Thank you. All right, so we're going to wrap that one up. We'll close that poll and I'll share the results. So I think that the crew leader, the QCI was because a lot of people didn't fit that criteria. So I guess we should have had, I don't have one yet. So, but a lot of energy auditors, analysts, and professionals. So again, thanks for participating. And I will give you one more. Get these back to back. There's one more at the end. We'll make sure you're still with us. All right, so I want to try and find out what is your code. And again, please use the question panels to help us with anything on here that actually did not fit my criteria. So 2009 or prior, but you're not testing. So 2006 didn't require testing. 2009 you are doing duct testing, or 12, but you're not doing blower door. There was a lot of people that adopted 12, but they chose to opt out of blower doors. If you're doing on 12 and you are doing both, that's phenomenal. And let us know what are your requirements. Some people are doing 5-year changes or 4. Some people are 7 for the blower door. Some people are doing the 3, which 12 requires. And we'll explain what all those kind of acronyms may mean to you. So, and if you're doing to 2015 and you're requiring a HERS score, we'd like to hear from you. So those are all great things to find out. And I forgot that California, you are on your own world out there. So we understand that yours are quite different requirements. So anyway, we got about 80% almost. So if again you want to chime in on anything that may not fit you, just to give your vote, please do. All right, and we will close it, and I'll show you what we got. So there's a fair amount of people that are clearly on the 2012 and doing both. So if you could help us out with what's your duct testing requirements, at this point you should be around 4% or a 4 CFM per 100 square feet, or your blower door, which for many people is going to be 3, which actually is a pretty shocking number. So, all right, I'll hide those and back to codes. I add this slide just for a lot of people that are code savvy or want to learn more about it. And somebody asked, are we referring to the ICC codes? Yes, the ICC codes are the international codes, and we're actually following the International Energy Conservation Code. So the IECC is the energy code which we're referring to. So some things that people think are energy codes are actually part of the residential, just general code. So you can see M is a mechanical part, the 1401, and the R's are part of the residential code in general. So they're not actually energy codes. So duct design and manual J, those are actually do not follow the IECC in terms of being listed there. They're actually in other places, but we think about some of these things as being in the energy code itself. So here's a basic overview as to duct testing itself. So total leakage requirement, which is leakage that could be inside the envelope or outside the envelope, depending on where the ducts are located, is 2009 and 2012. Leakage outdoors was removed in 2012. Some people still adopt it. I know that Energy Star, HERS Raters, and a variety of other third-party people believe in it, and it's a requirement. But in terms of just following the IECC code, it is not a requirement for 2012. I have a feeling it may come back as a priority, but more and more people are just putting the ducts in conditioned space and eliminating the reason for the test in general. So the blower door came into play in 2012 and stays in 2015. I live in Georgia, and we kind of follow the 2009, but we also require a blower door test. So if you have any kind of adoptions or exceptions or something else that may fit your criteria, we'd like to kind of get a feedback as to what it is that are your requirements or something that's different for you. These are the details. I do have a summary slide. So in general, for the 2009, you have leakage outdoors. You have whether the air handler is installed. There's a variety of options, and they obviously all have the exception of you don't have to test if the ducts are located in conditioned space or in the thermal envelope, depending on how your code reads. For 2012, things got a lot tighter. We went from allowing 12 CFM to 4, and that is a major jump for a lot of people that are doing this, or were kind of ignoring the code, or some people went straight to 12 and realized that actually you got to be on your game to get to that part. So for the 2009, again, this is just duct testing by itself, that you have a rough-in, which means that you just have the unit, or we do not have an air handler. So if you have the air handler and it's still in the rough-in stage, which means you don't have grills or a variety of other details, you're allowed 6 CFM. Without an air handler, you can get down to 4. A lot of places, the first thing to go in is the air handler. All right, and if you do post-construction, which is considered drywall is in usually just before occupancy, then you're allowed a leakage outdoors in 2009 still. So we're at 8 CFM, total leakage at 12. That's a pretty high number. I think that when they created the code and a lot of adoption, it was designed so that people would accept that they could complete this task, that they could actually get to 12, not a big deal, and knowing that what's coming around the corner was now I got to get to 4 CFM. So 12 was a way of getting people to accept to do this. 12 actually got them on their game in terms of tightening up the ductwork. Some places don't have this as an exception, or they took it out, but in general, 4 is the number that we're after. Leakage outdoors is gone in the actual code itself, but again, 4 CFM is your target goal to reach. So the reason that the IDL came around is because in the actual governing body of the IECC, who can perform this test was wide open. And the AHJ is something you would see regularly if you dig into the code, and that's the authority having jurisdiction. They can decide whatever they want, and they determine who can perform the tests. A lot of times, actually, it is one of the things that is listed as you could be IECC certified. So that means you actually pass the residential IECC and we're certified to do inspections, thus allow you to do this type of testing. A lot of places actually listed that you could be a HERS rater or BPI analyst or energy auditor or envelope professional. Those are actually in a lot of adoptions that are out there. And then after the adoptions, then came the IDL, and a lot of places are going back to add that. Some places also accept the DET, the duct and envelope tightness certification. And I know that Illinois and Alabama and Georgia, obviously, where it was created, also adopts some of those others. Texas also has its own kind of adoption for that. So the goal now is to really focus on something that is just a more simplified, basic way to actually do energy testing compliance. If you still are on the 2009 where you're only doing duct testing, this is where the IDL can kind of come into play, or make sure that builders understand this concept. So this is the first question I ask when a state kind of adopts the 2009 code is, who can perform the visual inspection of the air sealing checklist? That there is no blower door requirement if you do a visual check. So there's 17 items that go along with doing this visual air sealing check. So if you do this, then you don't have to do a blower door, because clearly you can go around and see leaks before they'll occur or have no pressure difference. So it's phenomenal what we can see with our eyes. In other states have learned that this did not go very well. But there is actually a requirement as to who's allowed to do this. Some places the builder can do it, some that's not allowed. So this is one place where if you have other jurisdictions or different counties that are on different codes, this is one place where that also can fit for you. So we're dealing with duct testing now. We're going to talk about measuring the area where each unit serves. So clearly, if I just have one unit, then I understand the square footage. There's a lot of things that are missing from the ICC code about how to actually do the measurements, a lot of stuff about the equipment, all the stuff that we may be used to in our industry are not in the code, and we just kind of bring them with us as part of our understanding about proper ways to do testing. So if you do have a house that may have two systems, your goal is to try to, and again, this isn't in the code, this is just kind of an understanding about what many people feel is the best practice. So people agree that it is not the best thing to add up floor area, do two tests, and divide it in half. That you really should be trying to separate square footage based upon each system that it serves, and then determine if each system is passing. So for here, I have two air handlers or two systems. One serves 1,000 square feet. The other one serves 1,400. And then I would do my test to find out if each of these is passing. And if they are, then the whole house actually complies. Here's some of the ways that I'm going to do some of the math. Again, this is kind of a brief overview about how to do some of this. It's not an in-depth. So if I did a total leakage, post-construction test, and on my gauge, I did the test, and I had 100 CFM at 25 pascals of leakage. And let's say the house was 2,400 square feet for that zone or for that total house. A lot of people refer to it as a percentage versus CFM per 100 square feet, because it's kind of easier to say. It's easier to say 4.5% versus 4.5 per 100 square foot. So that's just the same concept, whether it's percentage or per 100 square feet. So the 107 comes from the gauge, and that's what we're going to use in our calculation. So whenever you're doing this type of percentage, it always looks strange to do the math, and you should always end up with something that starts with 0 point something, all right? So we're doing 107 divided by 2,400, right? So it gives us 0.4458, and we can begin to kind of go down or simplify those numbers. So one of the things we're going to do is we're going to multiply it by 100 just to give it back to our percentage or our individual number per 100 square feet. So we're at 4.458. That's a hard thing to say. And one of the things you can also do is calculate those results in the Retrotech gauge automatically. So that's a nice feature. If you're taking your test or in general, I can get the CFM I needed and just change my results and get the CFM per 100 square feet directly in the gauge. So those are just nice features that Retrotech offers. All right, so I'm going to go through, again, many people out there, I can tell by your responses, you're BPI certified, that you're familiar with this, but I do have some people that aren't really familiar with a total leakage or leakage to outside test. So we're just going to kind of step through. So I have my house here. I have the air handler in the attic. I have a couple of supplies and 2 small returns. So we always start with sealing off the ductwork, anything that's not going to be connected with the duct tester itself, right? We're going to connect the flange and seal that off to the return or wherever we're going to run our test from. Sometimes you may do that at the air handler because that's the easiest place to make a connection if you have lots of returns. Otherwise, it'll be at the return should be the largest one and closest to the air handler. You connect your flex duct, connect your unit. And here we're going to be depressurizing. We recommend highly that you depressurize because it takes all of the seals around the ducts themselves and the registers and pulls them tight. So if you want to find out what's the lowest number, it is to make sure that you're sealing the system as tight as you can. And for the Retrotec system, that means actually having your ranges inside the flex duct. All right, so you connect your gauge. There's a blue tube that will go to, usually it's the register nearest the air handler. It doesn't have to be, and it's your goal to kind of make sure that you're actually getting pressures in further away from the system to make sure there isn't anything clogged or a significant issue. Connect your tubing and speed controls to the system itself, and you depressurize to 25. Basically, just tell it to set pressure 25. And so I have my results. So in this test, I have 140 CFM at 25 pascals. And if I do my math, I can find out that I'm 5.6 CFM per 100 square feet based upon that 2,400 square foot house that we had. Now you can also pressurize. There's no difference in the code on which way you can go or what's the preferred method. So for the Retrotec, you just turn the fan around. You don't need to change anything. Set pressure 25 and go. And you'll see that sometimes depressurization will have a slightly smaller number than pressurization. And that's because air, when it moves through openings, depending on the type of opening, doesn't always actually have the exact same type of flow through it. As well as sometimes you have small leaks around the duct seals. So in general, don't assume that if you turn the fan around, you're going to get the exact same number. They're usually fairly close, but never identical. So this is the exception, though. So my understanding, based upon all of the states that I've been to and done training, that it takes about 5 years before the builders realize, well, let's just put the ducts inside conditioned space, whether they decide to encapsulate the attic, whether they decide to literally bring them into the living area and just put soffits around them. But it takes about 5 years before they realize, oh, that's all we got to do, and everybody's happy because they get a much better performance, and of course they get to avoid the major issue of testing them. So I do have a couple slides as to why duct leakage is a major and significant play on the envelope or on the occupants in general. So, at the top I have the average home is 12% because in general that's 2009 leakage numbers. Of course, new homes would be tighter, but many homes, that I know you guys do for weatherization or other private stuff, can be up to 40%, which is a significant number. So if I have supply leakage here, what that actually does is puts a negative pressure on the house. So think of each of my arrows as actually a volume of air. So if I start off with 2 red volumes, I'm losing 1 in my supply. As the other one gets near the return, I need to get back to 2 arrows because it always is going to move the same amount of volume. So it's going to be grabbing air from outside. So it's basically going to be sucking on the house. So supply leaks suck because they suck on the house. They put it into a negative pressure. So let's say I had a hot water tank for an older home that might be exposed to this kind of pressure difference. Now, if I have issues like this, I could be bringing air directly down the flue, which actually is a significant issue. Most people don't associate duct leakage with backdrafting on hot water tanks, but clearly you can see it doesn't take a lot of pressure to actually do that. Same with return. If I have return leaks, I'm actually grabbing air from the attic or crawl space, which also is a nasty condition. And now I'm adding air to the system, so it has to have someplace to go. So I'm basically trying to actually push a little bit of air outside. If you had your druthers, then you might want to be a slightly positive pressure in general, but that's really a difficult thing to control with just leakage itself. So there's other ways to control that type of pressures in the house. And you can see by the pictures on the left that when you have that kind of leakage in a crawl space, it's all kinds of funky stuff that actually does show up in the indoor air quality or other issues in the house. I will touch briefly on leakage outdoors. Most people don't do this test unless you're doing more third party, or for some reason you're looking for another way to pass the IECC test because the duct leakage is failing and you want to see if what's on the outside of the envelope is enough to pass down to the 8% level. So to do a leakage outside test, you're going to have a blower door and a duct tester operating at the same time. right? So I try to come up with an illustration that might explain leakage to outdoors. When I first started, it took me a long time to really understand the concept as to what this is doing. So we're going to say that we have a couple of pipes here that have some leaks. All right. We could also consider these ducts that have the leaks. All right. So I'm leaking out of my pipes. Then I decide to take the one section of ducts and put it in the envelope or put it in a container. All right. Notice that the leaking that's on the top is going around the envelope or around the container, but all of the leakage that's inside the container is still leaking. And if I filled up the inside of my container with water or with equal pressure, then I can no longer leak any air out of the pipes that are inside the container or the conditioned area. So now I only end up with is leakage that's outside of my conditioned area, and that's considered leakage to outdoors. So hopefully that kind of illustrates the concept that we're trying to do is we're trying to separate any leakage that could be happening on the interior or inside of the house. You could have ducts that are running through walls. If you have a two-story house, you have a lot of ductwork that's moving down through the walls. All that can be eliminated with a blower door test. All right, and sometimes you actually have wall units or other conditions set. My goal is to find out what outside the envelope is the leakage. A couple of things to remember when you're doing that. Whatever way one fan is, the other fan must be doing the same thing. So if I'm pressurizing the duct system, I must be pressurizing the house. They must be moving air in the same direction. That's one of the always confusing things that happens. And you can do either one. You can pressurize the ducts and pressurize the house, which is the common way that people do this, right? So the system I have here is I'm pressurizing the ducts, so I must pressurize the house. So the blower door will take out or equalize all the pressure on the interior of the house, and then when the duct blower, which is what they call it in the code, equalizes the pressure, I no longer have the leakage that I had on the inside. I'm now only reading leakage to the outdoors. You can do the same for depressurization. It's a harder concept to visualize, but it works the same way. So if you're depressurizing your ducts and you're depressurizing the blower door, obviously, you can leave everything right the way it is and actually just do the test and without having to switch anything around or change anything. So clearly I'm depressurizing with the blower door, and I depressurize with the duct test, and it equalizes a neutral pressure there. And again, I have the same results for the most part. Any questions so far? If I lost anybody? All right, so I'll save my last poll for a few more minutes. So I'm going to go through blower door testing, all right, and just kind of an overview or some of the concepts. So this is where kind of the country gets divided, literally, in terms of what are the requirements. A lot of local jurisdictions or states have went one way and then decided that they're going to adopt another path, especially for smaller condo style, smaller units, because trying to do 3 air changes per hour on a unit that's less than 1,000 square feet, or in general 10,000 cubic feet or something like that, is really difficult. You really have to be on your game. The more volume you have, as you'll see, the chances are higher that you'll actually be able to pass this test. So here is the climate zone map. It's also ASHRAE's map, and also the IECC adopted this map in terms of what are your requirements. All right. So climate zones 1 and 2 are allowed to do 5 air changes per hour. That also includes Hawaii. But you see climate zone 1 is really Hawaii and a big chunk of Miami and a little bit further south there. So, and climate zone 2, Georgia has some climate zone 2, but they adopted it to be equally 3 all the way across. So for the rest of everybody, this is climate zones 3 through 8. Again, requiring 3 air changes per hour. And you can tell that's kind of the majority of those who are doing that test. So there are an enormous amount of local exceptions or adoptions. Just because they have these county lines on this map does not mean that that's actually always the case per se. So you may find that yours are slightly different, or you have a different way of adopting. Sometimes the entire state will just decide that we're just one, and that's the easiest way to monitor that or actually do compliance. Here are your 6 items required to do an energy code test. So try not to read any more into what these 6 items are, except exactly what it says there. These are actually from the code itself. So many of us are used to doing an enormous amount of stuff before a blower door, and even during it, to make sure that we are in compliance or doing the correct blower door test. So obviously you're going to have exterior windows and doors closed. Fireplace shall be closed, but you cannot seal it. Dampers can be closed but not sealed. If the dryer is not in place, you cannot seal the dryer opening. You're now trying to test and determine if the damper on the outside is now functioning, right? Open up all interior doors. All this stuff we're very familiar with in terms of what we're going to be for testing. It's kind of like steady state is what we're after. Don't seal anything, normal conditions, we can run our test. Again, there's no duct system or grills or registers are all wide open, so we're testing everything that's connected outside. So a variety of things are missing, if you may have caught that list. So we don't have much on combustion safety or how to prepare the house. We don't have anything about a baseline, how to measure the structure, any equipment requirements, whether it actually is in calibration or was ever calibrated, or what are you using for your testing methods. So these are things that are indirectly implied when you're doing your IDL. So you do have to do a baseline. They give you the measurement of the structure. We are working actually on trying to come up with a better math study course for that. But in general, you need to be able to understand how to measure the structure. And equipment requirements are just really making sure that you know that your equipment is in certification and in compliance, which is part of the IDL requirements. So here's a kind of an overview that the 2012 Conservation Code, again, you saw that it fits on one page. It's about 6 items versus the ResNet Chapter 8, which is 27 pages. Right. So clearly there is a place where you can find a better balance or be a little more diligent about how we do our blower doors. I mentioned this earlier. These are the air sealing items that are required. And if you really want to make sure you're passing the test, if you're working with a builder, this is new to you in terms of the code compliance, doing this visual inspection is a major resource in terms of making sure you will pass later. The problem with the blower door is that everything is done and you're doing your compliance test. So it's difficult to say, oh my gosh, we need to go and reseal all of the sill plates all around the entire house, removing drywall, baseboards, or things like that, or whatever kind of connection they may have that you can't get to. So the more you're on top of your game with this air sealing checklist, the higher probability you will to be able to pass that final test. So I always promote the south face, and that they actually have these illustrations. And these illustrations are all numbered, and they actually comply with and line up with the air barrier requirements in the codes themselves. And they're a phenomenal way of detailing and showing the typical stuff that we see in a house, and trying to make sure those are prevented, or you'll actually pass if you do this kind of a visual. So there's a lot of places where most builders are not used to the fact that knee walls now have to be kind of encapsulated on all 6 sides. There's fire rating issues and a whole lot of stuff that comes into play with that. So, this is now the kind of things you'll be seeing more on knee walls, is that they're finished from one side and insulated from the interior. These are the links that are to go and get the south face, all the illustrations, and they also made a field guide on how to do some of these things, how to actually seal the ductwork, or how to seal or install correctly the all 6 sides of a knee wall. So I'll leave those up for a second, and we'll list those out to you in the in your comments or in your feedback. So I usually try and do a challenge as to ask you, where is the air barrier? Because the thermal barrier is usually pretty obvious. It's where the insulation is. And the air barrier needs to be aligned. Those are the kind of details the codes hasn't really got adapted to. They do say that they need to be in conjunction with each other, and they have to be complete. You can't have gaps in your insulation or your air barrier anymore. So it's easy to do when you just got one room. But when you start chopping things up and adding multiple rooms, now my air barrier, which is typically the drywall, has now been cut or separated. Now I'm getting connections to attic or crawl space. We put some receptacles in or plumbing or other stuff. And now, as you're all familiar with, we get major connections to the attic or crawl space, a lot of air moving through interior or exterior walls. Of course, we decided to put air handlers and duct system and can lights and junction box and windows and all this other stuff in there. And all of these things are always what's breaking or interrupting the air barrier. And the reality is they become the air barrier that around the junction box or throughout the air handler or the can light, that's actually where the air barrier now goes into. So this is why the duct system is a crucial part of the blower door test, is that any leaks you have in your air handler or duct system are going to be incorporated in your blower door system, blower door test. Okay, so let's see. So we have an average home. All right, my sequence isn't working right. We put a bunch of holes in it. All right, my slide's not working. All right, sorry. I'm just going to try to go past it, see if I get it in slide. So I have this nice home that we cut a bunch of holes in. It looks like Swiss cheese. Of course, my uh, slide sequence didn't work right. I don't know. One thing was out of place. So the point is that we actually do have issues from outside to inside and internally. So there actually are an enormous amount of connections that go through top plates and other connections to the attic or crawl space, a large ductwork that's moving through floors. All those things are actually what creates an enormous amount of energy and air moving throughout the interior of the structure, let alone the outside of the structure. So there's multiple reasons to be controlling our air movement and flow. If you've not seen this, this comes from Building Science Corporation. So what I have on the left as an illustration is basically I have 2 sheets of drywall, 4x8 sheet of drywall, and the conditions are very normal. That I only have 75-degree temperature and a 50% relative humidity. I think many of us would kill to have that outside right now, but I'm in Atlanta and that's not the case. So on the left, we're talking about how much moisture will literally vapor diffusion will move through the drywall itself. And on the right, we just cut a 1-inch hole and find out how much moisture is going to move through the 1-inch hole as well as diffuse. So in 1 week, we end up with 1.5 pints of water just diffusing through the drywall itself. And on the right, we have 14 pints of drywall. So the point of this is showing that the air leakage that happens is a significant issue on our house. Not only is it moving hot air or cold air throughout the house, but it also is bringing moisture that is a huge latent load that makes us very uncomfortable or makes our systems work much harder. So again, this is actually a very significant illustration of that. So if we took the new code compliance house and we said, well, how big is an average hole for a code compliance house? It still could be almost 2 square feet and still be in compliance to be 3 or 5 air changes per hour. So if this is 1 square inch, you can imagine what 2 square feet could actually do to a house. Here's some just general overview about how the blower door works. Basically, it's a calibrated fan that has known openings in the middle and is set to a pressure differential, and it's able to measure that through the known openings to convert pressure to CFM. Is the simplest way to kind of describe that. So some of the things that it does, it allows us to compare a home in New Jersey to a home in Atlanta to a home in Nebraska, all trying to follow a similar criteria because we know that we had and documented the same type of setup. So it allows us to kind of confirm and can find leaks, and at least it's something that we can use as a comparison basis. So again, these are all similar slides that trying to illustrate that the blower door is we're depressurizing, we're bringing air out of the house, and I must be bringing air into the house to replace that, and I'm able to actually measure that air that's displaced. So I have a 50 Pascal pressure differential, and anywhere where I have known openings, I could actually measure that or go find them with my manometer, knowing that it actually will read around 50 pascals. So again, we're creating a pressure difference from inside to out, and the blower door will measure the CFM. And it kind of looks something like this as an illustration. So I set up my blower door, depressurize the house, and now it's starting to identify the infiltration areas. Again, many of them are actually difficult to find because they've all been hidden by much of the structure that's there. So there's a variety of things you can do, from pressure pans to just using your manometer with a small probe or a tube, and you can kind of go around and isolate. Closing certain doors throughout the house can actually identify when the number goes up or down as to whether or not that area or room may have significant leakage also. So I'm going to skip through the air changes per hour slide. It basically just shows that when the blower door is running, it goes through 6 times, and it measures that as a known number. So I do want to go through a few other things about the things you must do, whether you're doing ICC or other things. Sometimes we actually do existing homes and we show up and we didn't really go thoroughly into the crawl space or attic, evaluate the duct system, that the doors and the windows are locked. All those kind of things make a huge difference. So even if it is a brand new home, you want to make sure that there wasn't a water leak in the crawl space, or the attic doesn't have some kind of issue or missing shingles that would have actually affected what you might actually be doing to the house itself. The instructions that most people get when they're coming to do the IDL go through these kind of scenarios as to what are the issues or concerns when you're doing a blower door, and what are the issues in terms of combustion appliances and where they're at and where they're located and how they need to be turned to pilot. You usually don't turn them to off unless you have no other choice. So it goes through a whole laundry list of stuff. So many people who are taking the test do take a training, and it covers a lot of the safety issues that are there. Knowing that when you do a new house, you may or may not have gas on. It may not be on at all. They may or may not have had a fire in the fireplace yet, but chances are all these kind of conditions are already in a safe condition, but you need to make sure of that. So sometimes they'll run a fire to help the drywall mud dry sooner. So again, don't assume that it's a new house that these conditions may not exist. And again, your goal is to cause no harm to the homeowner, yourself, or do any damage to the house itself. When we're dealing calculations, we're dealing with volume for the blower door. And the more volume I have of the conditioned space, the better my chances are of passing the code or showing a better number for air changes per hour. I know a lot of people are after square footage of surface area. I know that's one of the things that Southface preaches and tries to use. Other third-party verifications use that for blower door, and it's one way to show leakage. This actually is trying to also show ventilation or air movement throughout the structure. So I feel in the future you'll end up doing both, kind of confirming if your house is tight, or also do you have enough air in the house that's moving through it. So the calculation for duct testing is very simple. It's kind of almost a percentage. You can do that in your head. Air changes per hour is a little more challenging. Unless you've been doing a lot of these, you kind of get a feel, or, oh, it should be around this number. But let's say my blower door number is 1900 CFM at 50 pascals. You're going to multiply that by 60 from turning minutes into hours, because we're after air changes per hours, and you divide that by the volume. All right. So again, I end up with 3.45 air changes at 50 pascals. And again, one of the awesome features that the Retrotec gauges do is they will provide the results in the gauge automatically. So they'll give me the CFM, I can change it and get my results. So it's very handy to have. This is a great little illustration. And there is a shortcut here on the bottom right that says you can take your CFM. So for instance, I had 4,257 CFM. I divide it by 1,000. It gives me about 4.3 square feet. So if I want to kind of know or tell the builder or tell the homeowner how big of an opening you have, here's a very simple way to shoot from your hip. The DM32 gauge also will do EQLA in the gauge automatically for you. Oh, I thought I had a thanks for coming slide. Maybe it's hidden. So that's kind of my overview. I will go back up, as I promised, to give you Matt's information.